Okay, good. So let's look at this proposition. So the proposition is just something we know intuitively. Are you following?
Yes, sir.
There are things you know intuitively. So if I have a so if I have A is less than B, are you following?
Yes, sir.
If I add any number to both sides, it will not affect the inequality. So whether you add a positive number or a negative number, so far it is still an integer that you have added, it will not affect the inequality. For instance, we know that 5 is less than 9, isn't it?
Yeah.
So 5 plus 10 will still be less than 9 plus 10. Nothing will change. Okay?
Okay.
5 minus 3 will still be less than 9 minus 3. So far, I am adding the same thing. Are you with me? On both sides. So if it is addition, no problem. Addition and subtraction. I can figure subtraction because we know that it is the basic operation is addition. Subtraction is just addition in disguise. Okay? Exactly.
Okay.
Okay. So this is true. But when it comes to that property B, for example, if you are dealing with inequality, so if I ask you to solve this, x plus 2 is less than 5. Okay, what would be your answer?
Now, x less than 3.
What if I do like this? What would be the answer?
So, okay.
What is the answer?
Have x less than 1. X less than 1.
Okay. What if I now do like this? What's the answer?
Okay. X greater than 1.
That is exactly what is explained in number 2 and 3. Sorry, in number 3 and 4. That is around number 2. Number 3 and 4.
Okay.
So if C is greater than 0, if you multiply both sides by C, if C is greater than 0, we're talking about positive numbers. If you multiply both sides by C, then the inequality will not change. But if C is less than 0, if you multiply both sides by C, the inequality will change. Okay?
Okay.
But for number 2, if we are only multiplying one side, okay, so if A is greater than B already, if A is less than B rather, A is less than or equal to B. If you multiply one side by C, automatically, okay, so there is a particular C that you will multiply by A such that it will be greater than B. Okay? if A is less than B, there is a particular positive number that you multiply by A such that the answer will be greater than B. Okay? No matter how big B is initially. So consider 2 less than 71, for instance. Are you with me?
Yes,
There is a particular C that you multiply by 2 such that this whole thing will be bigger than 71. The list of the B's you can use is 36. 2 times 36 is greater than 71. So 36 is the list of that C. Are you with me?
yes, sir.
So for this to be true, the C must be a positive C. Are you following? Talk to me. Take over here this for me.
So I can't hear you well. Your voice just
Okay. So, but do you understand what is going on? Do you understand what I'm saying?
yes, right.
Okay. So, if A is less than B originally, there is always a C, a positive C that we can multiply by A, which will now make it bigger than B. Okay. No matter how B was bigger than A initially. Okay. Hello?
Okay. Okay, sir. Okay, sir.
All right, good. Then, okay, I didn't talk about the trichotomy there. We call this first statement trichotomy. I think it is CH. So when we have two numbers, A and B, there are always three possibilities for those two numbers. It is either A is less than B, A is greater than B, or A equals to B. Okay? It has to be one of those things. So we call it trichotomy. That one is just normal. You understand? Hello? Hello? The network ẹ tún ti bẹ̀rẹ̀ ni. So, but at least, do you understand everything on this proposition? Does it make sense to you? Do you understand this proposition? Do you understand the proposition?
Yes, sir.
Okay. So maybe since the network is disturbing you, we should stop there. We can make it a daily thing. Are you following?
Yes, sir.
Even if it is just 40 minutes per day. But I will have to confirm the time my classes will start here. So if the time permits, it will always be from 7 to, let's just say 7 to 8. Hopefully, just at most 1 hour. So that the time in your network is in incorporate there. Okay?
Okay, sir.
So the next time we are going to start with this slide. So we are starting here next time. Okay?
Okay.
Any question before? At least we have fully explained everything we did the last time. We have not done anything new. Okay.
Oh,
Hello.
hello. What did you say, sir?
I said Nkotashileni is just a recap of everything we've done the last time. So we have not done anything new, and I believe you are now up to speed. You are clear with all this concept, so we can move on in the next class, right?
Yes.
We are starting here the next time. So talking about
Okay.
or taking Cosariros through the definitions since they are both within Robinson. So if I say if A equals to MB, like this, so what can we say about A and B? So if A is MB, then it means A is a multiple of B and B is a factor of A. We have talked about it when we're talking about divisibility. So if A equals to KB, then it means A is a multiple of B. That is, I will multiply B by something and I get to A. That's the meaning of multiple. A is a multiple of B. And the reverse statement is that B is a factor of A. Okay? And we can write it as B divides A. Okay?
Okay, sir.
So that means you have to put them in. So the next time we are going to talk about of course you know what prime numbers are. So we start from Euclidean algorithm next time. Okay?
Okay.
So we meet probably tomorrow. I'll tell you if the time has reached. Is tomorrow okay?
Yes, sir.
All right. So when I confirm the time, I'll send you. All right.
All right, sir. Thank
So
you,
you're welcome. Enjoy the rest of the day.
sir.